we have a session now, which is hopefully a session where it gets a little bit real, as they say, talking about concrete examples of people building great projects and companies. I think I've had a lot of good feedback on the session so far today, so I hope that people in the room agree with that. After these sessions, after these lightning pitches, the idea is that if you have questions, if you want to talk to them about what they're up to, then by all means do. However, our Meet the Speaker room is currently being used for another activity just in this session. So please do that, but maybe just take it outside and let's poach some of the FT Hub area or something. That's probably a good place to go and chat. So without further ado, I'd like to introduce Naref from Entropy, who's going to be presenting for the next 15 or so minutes, 10 minutes, and then you can take Q&A if you want. You got a mic, great, thank you.
Yes, work. Thank you. Hi everyone, so we are Entropy. It's a very young company and this is officially our first pitch, so be nice. Yeah, it works. Basically, I wanted to start with a story of my grandma, who's an avid YouTube user. She's 81 and she's on YouTube every day. And because of that, she started to believe a lot of conspiracy theories because YouTube algorithms are very inclined, if you search for something, to show you more conspiracy theories. If you click on it, it's more and more. So I saw a problem there that we've all been experiencing quite a lot. It's that what we think, what we see, what we listen to today, even sometimes how much we're paid, how much we spend, what we like, where we work, is decided by algorithms we have no control over. By saying we have no control over it means two things. They learn information about us and we don't know what information that is exactly, and then they propose us content for some reasons which are good for the company but not necessarily very good for ourselves. So they decide that we should serve a certain purpose and then we just get it. Recently, the incident with Cambridge Analytica was a perfect example of how that can work in real life. So at Entropy, we think this is the wrong way of doing things, and we want to change it completely. Entropy is a project and a framework to enable user-controlled data and experiences. So the way we do that is we decouple data, algorithms, and applications and bring them to the client. This means a couple of things. It means that the whole way that applications are built today has to change. It means that the data is kept on the user device. It doesn't go anywhere. The algorithm, the compute, is run on user device as well. And the application is just an interface that serves you whatever content you want. It can be a media application. It can be a recruitment app. It can be music, anything. Why this is useful? It's because if there is a problem with the algorithm that's serving you the wrong thing, it's easy to change it. It's also easy to control, and the cost is much lower. Today is the best time to do this. So there have been a couple of attempts to do this since 2004, then 2008 with the semantic web, and there are some projects today as well. Today is the best time because of a couple of reasons. Mobile hardware is really ready for machine learning. It can do quite complicated machine learning tasks. Secure multi-party computation is plausible today. And algorithms are becoming a commodity. A lot of people won't agree with this, but we see this happening more and more. If you look at TensorFlow and how it has changed from last year to this year, and how many people are contributing open source, you can see that building siloed algorithms is not going to be the way going forward. And of course, user privacy is more important today than ever. We see GDPR, we see a lot of attempts to follow this in the rest of the world. I'm actually really happy this is happening from Europe and we're leading this. So it is a very important question and it has to be addressed. So today is the best time to make this paradigm shift. Applications built with Entropy get a lot of cool stuff. They are going to be the best applications in the world, actually, and we want all the applications to be run with this principles, the standard, and the framework. Here's why. You get a warm start. So today, if you want to build an application to compete with any of the existing stuff, you don't know anything about the users. This normally means that it takes time for your application to make sense to them, and the churn is likely to be really high. You need less infrastructure. It costs you much less, probably less people to maintain that, which is quite nice. You can just deploy things easier and in a more efficient way. There's the data network effect, because the data vault is kept on the user. It means all the data is streamed from different applications. is collected in one place, which makes a single application more powerful the more applications join Entropy network. You get better performance. I was really worried whether this web app is going to work because I didn't know if we have good internet. With Entropy, you wouldn't have to worry about that because you can build offline first experiences just because everything is on the device. And you get safe usage of very private data. I don't think less data is ever going to be the answer as we're moving towards a data-heavy world. You need more data and more private data. It's just about how do you use it, how do you maintain secure access to it, and I'll tell you why. So a lot of companies today trying to get a piece of this. People are building stuff with Google Firebase. There's Blockstack in decentralized world who's doing exceptional things. We saw like the first decentralized applications on an app store in one place. But we think we're different. Obviously, we're also thinking about winning. So how do we win in this space and make sure next generation of applications are built on Entropy? Simple. Until now, all frameworks were about developer experience. Get this one line, make everything super easy to deploy, magical. Well, that is true. That is very useful. But we also think about the back end. So comparing to everything that we see today, Entropy is the only framework that comes with user data and compute. If you want to learn about how we do this, you can talk to me after. So let's see what applications are plausible with this framework, because use cases, that's what everyone asks in the blockchain and decentralized world. Understanding mental wellness from keyboard strokes. So this is a project we're launching in 2 months in collaboration with MIT and University of Illinois. It's called BioEffect. It's the world's first open knowledge keyboard that understands how you feel. So it detects 90% accurately if you're bipolar or if you have depression from your keyboard strokes. It's very hard. So they won ResearchKit Mood Challenge with Apple, but you can't take that data outside Apple because of privacy concerns, and you can just use it for research purposes. So last week was actually very sad regarding what we see happening with Anthony Bourdain or all these famous people taking their lives. And there's so many of them in the world that we don't know that are doing the same thing. This is a revolutionary thing to be able to stop that understanding early signals. And without a private way of dealing with user data and augmenting it, there's no way to do that. Our first application will be heavily focused on that and enable it in the wider world. Another thing, there are 3 billion people in the world who don't have a credit score. They literally can do nothing. They can't get a mortgage. They can't lend money. Like, they just don't have any data about themselves financially. And the credit scores are built in silos, which you can't really access. So for those people, phone data is an awesome way, and it's proven, to bootstrap a credit score. 2/3 of Chinese actually don't have a credit score, but the way they do it in China, they just take your data, the government, and decide whether they can give you money or whether you're a good citizen or a bad citizen. Now, there's a more private and people-friendly way of doing it, and you can do that using Entropy Framework, where your data is kept on the device, the model is computed on the device, and the algorithms gives a yes or no answer to you whether you want to access something. You can start by lending really small amounts and then going to higher amounts. This is an idea that we came up with or heard very recently that can be very useful. A lot of people who have different interests and want to meet different people have a problem scheduling those meetings. It's an optimization problem. Now, if you're in a community that's also worried about privacy, like the polyamorous, for instance, there are quite a lot of I couldn't find the market numbers on this, but I'm sure there are a lot of them. It's very hard to schedule that and to keep the calendar private. Great application for something like Entropy, where you can do the compute, the optimization on device, and then go meet whoever you want at the right time with no effort. I'm not in that community. So yeah, recruitment is another area where you sort of compute a persona model and then it matches with the right job. So the right job finds you or you find the right job. There's a lot of place for bias in this. And with something like Entropy, you not only make sure that your private data is used to match you with the right thing, but you also make sure that doesn't go anywhere else or your employer doesn't get that data afterwards. This is an application we deeply care about. Life is very short, and all of us are going to die if we want it or not. Some people believe they are not going to die, but I won't get to that. So imagine if you live this one life, but imagine if you could actually back up your mind. Imagine like everything you do digitally outside, all your experiences could be recorded securely and kept on the permanent web. It's basically, if you've heard about cryogenic freezing, a lot of people try to freeze their brain so that at some point you can understand the data and then maybe upload it to a computer and bring you back. This is a much easier way of doing that. You could just upload your digital persona, and that data would be interpretable in years to come, will be kept securely. You can assign your key to the people you want to leave your legacy to, and then just come back or just leave that legacy for years, depending on what we all fancy. I know this is crazy, but please at least smile. There is a market for this. The equipment market is $30 billion for cryogenic freezing, and this is like less intrusive than freezing your brain, and looks much better as well. Yeah, so we're talking about the permanent web a lot in the decentralized world. This is about the permanent you kept securely for yourself and others. Thank you.
That was fantastic. I thought you covered use cases from love to death to loans to depression. If there isn't something to drive it amongst all those, then what are we going to do?
I'm happy to take questions at this time.
Any questions for Nare on the? What?
Yeah. So, to be honest, the best way to answer that question would be after we have deployed like the first application and we would know the right answer. We are not going completely crazy about a serverless model or no quality assurance at all. We're even thinking about a curation of applications and a curation of algorithms, if that's possible. And you can do it even in a decentralized way, take like token curated registries. So all of that will be kind of thought through and used as it comes necessary. So we will not go, yeah, you don't need it because it's against the principles. You can do that within the decentralized principles and make sure those, because if the algorithms go rogue and there's no control system, that can be much worse than what we have with a huge centralized server today. At least they are under the loop of public, and there can be certain actions taken. Whereas if it's from somewhere you don't know where it's coming from, it can be much crazier. So it's an important question. Yeah.
Sounds like another network to be built.
Yeah.
More? There was one more here.
Yeah. It's an open source, completely for-profit organization. So we eat our own dog food. We believe the framework should be open source, and you should make money on the application. So the first application, which is a mental health cover using the decentralized keyboard, will be the moneymaker for this. And then there are a lot of ideas today which are quite nice about also monetizing open source. But once we have the network together, we'll get thinking about that.
Super. Thank you so much. Big round of applause, please, Entropy. And if you want to have further chats, as I said, maybe outside in the sunshine if they want to do that in the FT Hub. Great. So it gives me great pleasure now to introduce somebody I must admit I've known for a little while, Robert Norton, to talk about Verisat.
Thanks, John. So I'm going to give you a little bit of an overview of what we do in the art world. So if no one's interested in art, it's probably a good time to leave. My name is Robert Norton, long-time entrepreneur. And in the last 10 years, for better or worse, I've stuck with building art and technology websites. I started with Saatchi Online in 2009. It's now the largest platform for independent artists to sell work directly. And then we did a digital art platform called Sedition. And then in 2013, after I left that, one of the artists we worked with, Casey Reese, wrote to me about blockchain. And he said, hey, Robert, I think you should look at this technology, both for digital and physical certification and verification with application for the art market. I didn't really know too much back then. I wasn't one of the early Bitcoin enthusiasts. And as I started to look into it, it seemed that there was incredibly useful for the art market. If you're not familiar with the art market, it's a $67 billion a year industry, and it's characterized really by the twin requirements of opacity and transparency. And up until, I would say, probably 20 years ago, it was pretty much all opaque, sort of information silos, paper records, fragmented databases. And obviously, with all the work with e-commerce and Instagram and image search, it's become, by default, more transparent. But it is still by no means an industry that encourages or requires transparency at the highest level. You see this by the level of fraudulent activity that takes place. These are some of the headlines in the last 18 months. And when I started looking into this, it was really quite shocking. You saw sort of galleries that have been around for 150 years, such as the Knoedler Gallery in New York, selling fake Rothkos to none other than the chairman of Sotheby's himself. And you couldn't actually kind of make this up, but it actually affects artists at the highest level, but it also affects artists at a kind of more affordable price point, limited edition prints. There was recently a case in New York of a bunch of fraudulent dealers that were making fake Damien Hirst prints and selling them on e-commerce platforms. So the FBI estimates that the annual size of fraudulent activity in the art market is around $6 billion. So it's about 10% of the overall market. But what's interesting is when you compare that to the actual size of the online market, it's actually greater than the size of the online art market. And that's putting together all the activities of auction houses and the well-known online art brands that are out there. Artsy, ArtNet, Padlate, for example. One of the reasons why I believe the online art market has kind of held back is because of the problems of trust. And when I was at AOL in 1996 and we launched e-commerce here in the UK, the big challenge back then was getting people to trust putting their credit card into the computer. Well, we all know how far we've come. The big issue when it comes to buying arts and collectibles online is knowing if the work is authentic, and secondly, does the person selling you the work have the authority to sell it to you? And this is where the blockchain can really help. So I'm going to explain a little bit about what we've been doing in the last 3 years at Verisart. So we started with this idea that having a paper certificate and then a written provenance, and then somebody, some authority, some artist foundation or gallery telling you that this record and story is true has been unhelpful with regards to the prevalence of fraudulent activity. So we thought, well, if we can bind this together using a distributed ledger technology, we could make a better product for the market. So a lot of people ask, well, do you actually tag the work? Do you use synthetic DNA or RFID chips or anything like that? The reality is that every different medium will require a different tagging solution. So today, if you're buying an old master painting, you'll actually use something like a pigment ink analysis report, or you might take a multispectral image of it. Now, if you're sending a signed photographic print, you might put a sticker or a seal on the back of it. So our view at Verisart is that we have an evidentiary and endorsable platform that uses the Bitcoin blockchain to record proofs of existence, and it's up to people what they want to put into those statements. We differentiate in our system between verified issuers, which is kind of the artist shadowed out here in black, versus unverified verifiable claims, which are collectors themselves. And our view is, and our focus as a business is to sign up verified issuers. So here's one of the first artists we signed up, Shepard Fairey. He's the third most followed artist on Instagram after JR and Banksy. And when I first met Shepard in 2009 in LA, he spent the whole meeting signing posters because he's known for doing these flash sales where he sells out limited edition runs at a very affordable price point, but he also sells at the highest price point to museums. He's in most major American museum collections. So this was Shepard Fairey's certificate of authenticity before we met him. And it's pretty much the same as any certificate of authenticity that you might find in the art world. It has a picture of the work, it has a description, materials, year of production, artist signature. Now, many of you here are experts in blockchain, but this presentation is designed for more the art market participants. But the three things that we do is that we basically timestamp it, has a unique blockchain address, has a public key, And this has been pretty popular. So you can see top right there, that's where the timestamp's coming from, and then you can see the URL, which is an important point because the work still needs to be published, and the blockchain address and a QR code. We started with this app in 2015. We gave it out to a bunch of artists thinking if you give them an easier tool, they'll make better records. It was, despite my knowledge of the art market, that was not the correct assumption. Artists fundamentally like to create, not to really register or record their works. But where we found traction in the last 7 or 8 months has been with regards to partners who sell works online and want to create unique certification for the works they sell. So the first partnership deal we did was a European e-commerce print site called Avon Arte. They work with a couple of hundred of the well-known artists, gallery-represented artists in Europe. And they actually now promote this as a value that for their buyers, which is that they're getting a blockchain certificate for their record. This is one of the Avon Arte certificates. They can customize it as well. We also work with Paddle 8, the online auction house. So works that are sold through them now carry our certificates. That was a deal we announced a few months ago. And then quite recently, just the month before last, we signed a deal with DAX, which is a Design and Artist Copyright Society here in the UK. They represent over 100,000 artists across Europe and have collected to date about 100 million in artist resale rights. And this is where I think it gets really interesting, because blockchain certification, in my mind, has always been the first step to smart contracts, and then that's the second step towards asset securitization. And while there are lots of businesses that look at it from enforcing either a new form of transparency onto the market or a new form of economic model of ownership, our view is that it really requires the artist to participate in creating these certificates to begin with before you can actually build additional models. This is a deal that we announced last month. It's Art Systems. They're the largest inventory management platform for the art market in North America. It takes us into about 2,200 galleries. And this is, again, something that I think is really critical when trying to build blockchain businesses actually result in partner revenues and growing partner revenues, is you have to make it easy for those partners. And if you're going to force them to take their data from one system and recreate it in your system just to create your trusted certificate of authenticity, that's often too big a hurdle for many to jump through. One of our board advisors, we have two. One is Peter Todd, who's a well-known Bitcoin maximalist, and the other is Ahmed Elgamal, who is a professor of art and artificial intelligence at Rutgers University. And this is an area that we're really actively focused on right now, in the same way that 3 years ago we were actively focused on how we could use the Bitcoin blockchain for an art application. So at Verisart, we're really doing 3 things. We're taking the best classification standards for cultural objects, something called CDOC. We use structural vocabulary from Getty Research Institute, because our view is that when you're making these statements, in many cases they will be purely public statements in the future. So you want the ontology that you're using to be understood by machines and linked open data compliant. The second thing we're doing is using, still today, the Bitcoin blockchain. But the third thing is the image identification. So we're creating these unique fingerprints that allow people to take a picture of a work and see if title exists. And where we're really focusing our attention now with Ahmed's work is moving beyond that to actually very specific fingerprints that will allow you to determine if one painting is real and another one is fake based on brushstroke. So Ahmed's been doing some really interesting work. Some of it was published towards the end of last year in an MIT MIT review. And it's really about authenticating work at a brushstroke level. And I believe it will get there in terms of an application that we can actually use and sell by the end of this year. There's an invitation. If you want to test out the platform, type in leaders. You can make a statement yourself. And thank you very much.
Thank you, Robert. So, who here is culturally inclined and would like to pile into some questions? Over here.
Fantastic innovation. I'm just wondering, what happens if I take a real certificate and sell it with a fake piece of artwork, or just take a photocopy of the certificate and put it on a fake piece? I don't understand how the certificate relates to the authenticity of the physical bit of art.
Yeah, so the first point is that we differentiate in our system between certificates of authenticity and certificates. So if I'm an artist and I've created a certificate of authenticity, I've not allowed, other people will not be able to come into our system and use that artist's name or that artist's signature to create works by that artist. So that's the kind of first thing. There's a consistency in terms of the public key that's associated to that artist's account. The second thing is that you're constraining, and that's why, as I said, the URL is very important. You have to publish it. If you're not allowing the new person to be able to see that you have the authority to transfer the certificate, then that's a problem. So when you go through certificate transfer in our system, it's very clear that this public key is transferring this certificate to this public key, and you can see that, and you can see that the certificate's been moved. So that's how we get around it.
I mean, you had sort of some physical certificates or some screenshots there. What happens if I take one of those screenshots and put it on my fake Mona Lisa?
Yeah, I mean, you can do that, but what's the value of doing that, right? You still, the point is that the certificate is ascribed to the specific owner. So you still have to have the authority to transfer it. You could fake a copy of the certificate, but you wouldn't necessarily be able to fake the ability to, you wouldn't be able to fake the ability to transfer it because of the fact that it's a unique record.
Thank you.
Alex?
Yeah. So you said that you said that you built your project on the Bitcoin blockchain, and then at some point in the presentation you talked about how if, because you're putting a lot of data on the Bitcoin blockchain, there was interesting applications with smart contracts and more complicated stuff. But aren't you worried that because it is the Bitcoin blockchain, there's a limitation on how complex you can go in terms of smart contracts? And
yeah, it's a good question. But in 2015, when we started, we didn't have any other options. So we're largely as a result of our legacy. And for what we're doing, I still think it's when I go and speak to these galleries and auction houses and artist studios, it helps the fact that we're using the world's most widely distributed ledger technology.
Super. We might need to move on, unfortunately, just because we're starting to run tight on time for this particular section. Not meaning to deprive you of stage time, Robert. Thank you very much. So I almost said earlier that it was nice and cool in here. Well, I did say that, I guess, but it seems to be hotting up. So I hope everybody is okay. Next up, we have Toby and Thomas from Fetch.ai down here. Thanks, guys.
Thanks very much. Hey, everybody. We're trying to figure out which one of these buttons does that. Excellent. I'm Toby Simpson. I'm co-founder and CTO of Fetch.ai, and I'll be joined in a second by Thomas, Chief Scientific Officer and fellow co-founder. I'm here today to talk a bit about Fetch. Now, at the moment, we live in a world, well, that we believe is less than optimized for us. And that's because it's getting increasingly more complicated. And the problems that we generally bump into in our day-to-day lives involve a larger and larger number of moving parts. And it's getting much, much harder for us as individuals to take into account everything that we could use in order to solve those problems. And also, we have worlds that we have to do all the hard work in adapting to, rather than worlds that might, for example, adapt to us. And you sort of figure that after all this time, that actually we should be at a point where computers are fast enough and more powerful enough, and the software solutions that we've got are cool enough, so that these things could figure out how to adapt to us. And then there's discovery. Right now, the global network, believe it or not, is optimized for human beings to use, although it may not seem like that sometimes, but it is certainly not optimized for machines to use. And by machines, I'm talking about digital entities, artificial intelligences, although I prefer the phrase digital intelligence because AI, or artificial intelligence, implies something that's not real. And now we have a situation also where a lot of the data that we would like to use in our day-to-day lives is centralized. It's locked out of our reach and also out of our control, which is becoming increasingly important to us as individuals. So what would be a win in this situation? What kind of solution could we come up with that would solve some of those problems? Well, we wanted something that could connect anything and everything together, regardless of the language they spoke and regardless of the protocols they used. We wanted a world that was able to organize itself to suit the person who was viewing it, rather than something that you had to organize yourself to fit. And we wanted data to sell itself. In a recent paper by Outlier Ventures, they talk a lot about the fact that actually what's interesting is not necessarily the data that we use, but the data that we don't use. And that's either because we don't know it's there, or it's too much hassle to exploit, or the cost to exploit it exceeds its value. And that's terribly wasteful. It means there's all this information that we could bring into play that we never do because we can't, for all of those reasons. And then certainly on decentralized systems, you have proof of work. This will probably go down in history, particularly as it stands right now, as one of the most extraordinary wastes of computing power that human beings have ever conceived. And the idea that perhaps you could repurpose that to do something useful is extremely attractive. And then we wanted to make Web 3.0 a place you could go. We wanted to put geography on the network. And that's really, really important for machines because they need somewhere to live, somewhere to go, a method of seeing things and looking in a direction and gathering information that's relevant to them. And we wanted to see if we could build a collective superintelligence on a massive decentralized network that would provide the individuals with the ability to get smarter themselves. And that's where we came up with Fetch. Fetch is a decentralized digital world in which useful economic activity can take place. That activity is done by digital representatives or digital entities that we call autonomous economic agents. They can act on your behalf, they can act on their own behalf, and they can work together or alone to solve very complicated problems. And those representatives, they can represent you, they could represent a piece of data, they could represent a segment of infrastructure, or indeed services. I need to press that button, don't I? And then their view on the world, their unique view on the world, a view that has been tailored specifically for them, is provided by the Open Economic Framework, which acts as an interface to this new digital world. And the smart ledger is what's underpinning all this. Now, we couldn't use an existing ledger technology because of the scales involved. We very rapidly realized that if we had situations where we had maybe millions or indeed billions of autonomous economic agents working together, we weren't going to be able to get the scale with existing solutions. If a problem that has been solved involves, say, the work of maybe 50 or 100 different agents, it's very easy to see how we very, very quickly need a whole new level of scalability. Now, we thought we'd cover a bunch of the technology things just to talk about how we actually came up with this stuff. And this is the ledger. We looked very carefully at how we could scale things like the Bitcoin protocol, the Ethereum protocol, to try and get the kind of level of scale that we needed. And we ended up with a unique solution to all of this that involved parallelizing all of this quite cleverly. So in this particular case, we've got 4 individual transaction lanes. Now, where the transactions, they're named after cities not because it's geographically placed, but because it's a convenient method of talking about it. In this case, you've got one in each of those places. They don't collide with each other, so they can be executed in parallel. Now we've got a different situation where you've got 2 transactions that are taking place which straddle multiple lanes because they involve different parties. Now, what's interesting about this is that if you can arrange them all so that the ones that don't affect each other are executed in parallel, then you have something very interesting. Now, imagine if that had, say, 100, 200, or 400 lanes, and you were looking at a big depth. It actually becomes a bit of a Tetris problem. And it turns out that arranging all of those blocks in this way for an optimal solution is actually quite computationally hard. And that's what led us to consider, well, what if we could get the consensus mechanism on the network to actually arrange all of this as part of proof of work? Because then we'd have a genuinely useful proof of work where we were actually optimizing the performance of the network by all the nodes on the system. Now, in order to do that, we needed to come up with a cool method of deciding who it is or whose optimized block actually works. And we use a kind of directed acyclic graph for this. I'm just going to pop this forward a couple so I can show you how this works. Now, each one of those squares represents one of those optimized blocks where all the transactions have been arranged to occupy as many of the lanes as possible and to increase the parallel usage of all of those things. Now, in this particular case, the yellow one, the one circled in yellow, is the one with the highest fees. Now, the elected leader, who I'll come to in a tick, is optimized or incentivized to pick that person because the fees get split between the person who submitted that block originally and the leader who elected to put it in there. And then the one that's circled in red, that's the one that had the highest occupancy, and that becomes the next elected leader. So you've got a mechanism where everybody is incentivized to try and optimize as quickly as possible because they might end up as the next elected leader, but also you also get the ability of, if you are the elected leader, then you get to share the fees out. And so that process continues. There is a method in the protocol to ensure that if someone doesn't pick a block when they should, then it falls to the next person, the person after that. Now, this happens quite quickly because, of course, you're heavily incentivized to do that because you can get to pick up the fees from doing so. But then we thought, well, actually, why stop there? We don't just have to worry about optimizing the network performance using this. We might be able to do something really interesting. We might be able to use the consensus mechanism to construct intelligence about the network, trust information, and more. And to talk more about that, I want to introduce Thomas Hain.
Thanks, Toby. Which button? The green one. Right. So yeah. So this is about the ledgers, but of course, you said green. Okay. Right. Normally, sort of blockchains and sort of the ones that Toby talked about are usually thought about in the context of sort of moving money and value around. But there is, in the context of Fetch, there's a lot more of information there that pertains to what we want to use this, right? This is a platform for agents that engage, that talk to each other. And there's behavior, there are certain attributes, there are certain attributes that we can harvest and that we can look at and we can use to make not only the ledger better, but we can also enhance the whole system by learning about what is actually going on in that digital world. So we have access to history, we have access to what has happened, what have agents done so far. We have access to context. Context is what kind of transactions are coming in now, which agents engage. We also have, through the useful proof of work, we have actually also an additional element that has to do with computation, because in the way the ledger is built, we can choose what computation is built on, and that is information about the ledger too. And we can take all of that information and we can plug it into machine learning systems, and we get different concepts out, concepts that enhance us in many different ways. We get belief out, belief in the trust of the transactions, belief in the trust of, for example, miners, belief in the trust of the credibility of nodes. We can get confidence out, confidence on if a transaction is useful or not, if a certain behavior is typical or not. We can also get, and that is the really key thing that will drive us a lot forward, we also get semantics. Semantics about actions rather than just about money at that side. And we use all of that information to go in all directions. So we, on the one side, improve the smart ledger. We also use a lot of that information in the open economic framework. And we also are working towards something which we refer to as the collective superintelligence, because we can combine out of a sudden, through the semantics analysis, we can combine out of a sudden processes and stages from different agents that have never been combined before and wouldn't have been possible otherwise. And that gets us really excited in that way. So, of course, there's lots of elements of machine learning in the Fetch system, and I don't have the time to talk about all of them. So I'm just focusing on two elements in the ledger that are interesting. And the first one is sort of probabilistic trust. And just to illustrate a relatively simple scenario, you have a transaction coming in that goes into a ledger node and gets transferred forward. So the node then receives that transaction, applies a signature, and then passes it on to the next node that applies a signature as well, and so on. And so as the transaction propagates through the network, there's more and more information gathered about the transaction itself. And the fact that a node accepts a transaction is a meaningful process. So in other words, it wouldn't do that if it believes the transaction is somehow fraudulent. So what we can do is actually treat this information as a sequence information that can be fed into a machine learning system. A machine learning system that then now can build up trust, belief in what the particular actors in this particular systems do with relationship to the transaction, and that empowers us to make decisions much faster than we were able to do before. So that's one example. The other example is, still struggling with the buttons. The other example is extracting semantics or meaning from the actions of the ledgers themselves. Think about a simple example. You have a sort of car, and there is an autonomous agent associated with the behaviors of cars. And of course, there are certain actions that the car takes and certain queries that come along. So you have sort of at a certain point, you have query where the nearest charge point is for your electric car. And then you sort of have other queries about the weather and your journey. You want to plan the route for your journey. You have all these actions that come in over a period of time. That characterizes that particular agent in what it does and what it typically needs and what kind of information it can also provide to others. And with that, we can sort of have multimodal data. We have a lot of information about these different kinds of actions, and we can feed them again into a machine learning system. And there is a really interesting change in the field of machine learning and AI that allows us to now take information unsupervised like this and obtain what we call semantics or embeddings from it. So embeddings that are a representation about what you do, what you typically behave on, and how you act. And you can use that information to, again, obtain trust. If there would be an unusual event here, you would be able to detect it, but also it allows us to connect different agents with different behaviors that that before would have been very tedious to connect. There's a lot of opportunity here that we see, and there's a lot of elements that I'm afraid I don't have the time to talk about. There's unsupervised learning here, but there's also supervised learning here, because we can see what the agents do. We can get feedback on if what we have learned about agents is correct or not, implicit or explicit, and that's all that there is I have time for. So thank you very much for this. Fetch is an enabling technology. It will allow you to do many, many different things, and there's lots of exciting things and news more to come. Thank you.
Great stuff. So questions for Toby and Thomas, and before you ask a question, if you could just give like a 30-second précis of how the system works, then we know that we're all on the same page. That obviously is it's a fundamental enabling technology, and it has some sophistication to it. Should we leave it at that?
That was a good one.
Any questions for the team in plenary? Otherwise, you can go down here.
Hello. So you're using the DAG consensus algorithm and infrastructure, but are you susceptible to the issues that come with DAGs, just like other projects, etc., or have you found some kind of magic to solve that?
Well, I would just say some kind of magic, but actually, essentially, where strict global ordering is required, those transactions that are organized on transaction lanes, they go down onto a single dimension blockchain type structure. The DAG is only there, I guess, as a sort of a side DAG to provide a mechanism for the consensus to collect all of the possible results that are coming from everybody who's submitting either block optimizations or trust information or anything else that goes through that, because it can scale to take all of that and it's not quite so important in the same way. So yeah, it's a combination of those technologies. Fetch isn't built on a DAG. It's just that that's one component that ensures that we get the scalability where we need it.
Thank you.
One more. Over here. Thank you. There's a mic coming to you just there.
Just wanted to ask, what's your pilot project? I just want to know like a real-life use case for it as well.
Sorry?
What's a real-life use case? Have you got a pilot project for
Oh,
Fetch?
right, yeah. Okay, actually, I'm going to two answers there. One is, just quickly so you know where we are with all of this, the key innovations involved in this technology do actually work. We have a private testnet working in our office with it. We recognize that in an area where we're building something that can do so much, there's a risk that if we don't focus somewhere, it'd be very difficult to make that stuff happen. And we've identified a number of areas where the ability for Fetch to solve problems involving lots of moving parts is very effective. One of those is transportation. Another one is logistics, and another one is energy usage. Those are three areas where we're working and talking with various partners and other people in order to bring Fetch to life.
Good. Important and classic question. What problem are we going to solve? Great. So, once again, Fetch. Thanks, guys. Thank you. See you on that.